Hey everyone, this is an assignment from the System Design Cohort on ChaiCode. So in this video, we'll discuss a system similar to LeetCode, the platform developer used to practice coding interview problems. So in this video, we'll cover functional requirements, high-level architecture, code execution system, and a little bit of scaling to millions of users. So let's begin with requirements. So what are the requirement we need? Basically, we need some functional requirements. So let's uh, write down the requirement first. Okay, so first of all we need a authentication system, so user will sign up or logged in. Then basically we need um, browse problems like we can say browse coding problems, right? Next you can add submit code, right? Okay, what will be the next? Run the code. Run the code against test case. Okay, so next we can add see results, so user will see their results. Okay, and they can also track, we can add another step, we can they can also track their submission. Okay, okay, like, and they can view leaderboard. Those are the basically functional requirement. And also we can add basically um, some discussions later on. Okay, so apart from the functional requirement, we can add non-functional requirement here. So we can like design a system which can scalable and high availability. So and also for the LeetCode type, LeetCode type system design, we need to secure the code executions, okay, and the fault tolerance also. So thousands of users may submit their code simultaneously, so the system must be safely executed, right? It can be some malicious code, it can be untrusted code, all right? So need to execute the code safely. So for this we can literally saw the code execution engine. So basically those are the requirements. So yeah, now moving forward the high level architecture. So I will draw a high level architecture. Okay, so first of all the users, right? First of all the users. So user will like from web or from you can say mobile application also. Next we can add a CDN here. Yeah, makes sense because some like we are saying like the coding problems, uh, they can browse the coding problem, right? So after logged in they can access the coding problems uh, using CDN also, right? Like whatever static things are there in our system, we can serve as CDN, right? Okay, next is load balancer. We can add here one load balancer. Okay, This is our load balancer. What will be the next? Then now we are adding API gateway. Now we are adding an API gateway. Okay. Okay. Now we are adding the API gateway. This is our API gateway. Now what happened? When user request request or browse up coding problems, like API gateway will route or any submit any code. API gateway will route another like multiple service. So we are here create 3 services. One is problem service, another is code execute or submission service. Okay, one is problem service. First of all, write problem service here. Next is you can say submission service. Okay, another is user service. Like from there they can you can say they can authenticate. Okay, their rank will store whatever users. Those logics are written here. Okay, those logic are written here. So now we can add DBs. We can add like single DB also, but for scalable system, for scalability, we can add multiple DB for multiple service. Okay, so for this we can add, for problem service we can add problem DB, right? We can add problem DB. Next, for the submission we can add submission DB, and as same we have user DB, right? Makes sense? So yeah, so in this section, in this high level architecture, we see like 3 layers are there. Basically we are in a high level we can add 3 layers. The first layer is basically the client layer. This is our client layer. Then we can add backend layer and database layer. So 3 layers are like we can divide it. So in now coming to the problem service. In the problem service we can manage all the coding problems here, right, and store in the problem DB. In the submission service we can handle code submissions, and in user service we can handle the accounts, the user accounts like authentications, and users like any user can add their profiles, whatever, everything is saved in the user DB, right? Makes sense? I think next we can go to the code submission part, like the main flow. Okay, so in this code submission part we can add some code submission flow first, then understand how the code submit. So now we can write down a code submission flow, like how code will submit it. Okay, code submission flow. Yeah, first of all user will submit a code, very basic thing. User will submit a code, and like API gateway route into which part? API gateway route into basically the submission service part, as we see here, right? API gateway route into submission service part here. So first user submit code, so you can write here submit code. Next is API gateway. This is your API gateway. So after that, API gateway will route into the submission service. So after going to submission service, what will happen? We need to store the submission before execute like the code, whatever. We need to store the submission first. Okay, so let's store the submission. Let's store it. So in which part it will store? Basically the submission DB. In the submission DB it will store. So the submission is done. Now this submission will go to into the, like this is a job basically. Those jobs are pushed into queue, right? Those jobs are pushed into queue. You can use we can use SQS, right? And now those jobs are like after going to the queue, we can add like workers, like judge workers, you can say, like those workers like I can specify the judge worker here. Okay, or you can here say like those are the like basically the multiple. We can also push the multiple workers depend on the scaling or our architecture. And now the main part, the heart of the LeetCode, basically the execution code. Like the code will execute using the like code execution engine. Now in the flow we can execute here, we can execute the code and then return the result from here, then return the result from here. Make sense? Yeah. Okay, return the result. So what will happen here? So let's recap once. So user will submit the code going to the API gateway, and then API gateway route the submission service. Then this submission is stored into the submission DB, and then the job pushed into the queue, right? The job after like stored the submission, job will push into the queue and worker execute the code. Then worker execute the code, return the results. So what will the benefits? Basically those flow will handle the spikes, right? And also decouples the services, right? So now going to the code execution part, like basically the judge system. So explaining and like the core of LeetCode. Let's draw. So in the code execution, basically the judge system basically. So explaining this judge system. Okay, what will happen here? Like we are using the queue basically here. So all the jobs are pushed into the queue one by one, and then here the judge worker basically implemented. So we are adding here judge workers here, right? So here we can use any like judge 0, which is basically open source for executing the code. So in this worker, after this worker we can add like container. We can add Docker container, right? And we can add test case runner also here. Okay, after that we can generate the result. So result generator, this is our basically flow of code execution. So running user code directly on server, it's very dangerous. So we can use like environments like this, right? We can use environments. So in each submission like starts a container. Like if user submit 5, so those 5 like code will spin up with 5 containers. Then basically load the test cases also and execute the code, and then return the results. Okay, so it can be the result can be like accepted, the answer will be wrong, and the TLE also there. Okay, and runtime error is also here. So this is basically the code execution of jar system, how they working. So after that we can going to the secure execution. So before going to the secure execution, like I will add this thing. Okay, this. So in our high level architecture we can like see here in the submission service we can add the submission DB. So after storing the submission DB, as we can see here, after storing the submission DB, the queues are there, like, so we can add here queues basically. So here we can add queues. I think it's visible properly. So the message queue, we can use Amazon SQS for this service. Okay, so next in this queue, you can say message queue for better visibility. So it can be used SQS. Makes sense? Okay. Now what will happen here? So if we see every job pushed in the queue, then judge worker picked up one by one, right? So we can add here for judge workers here. So in my case I can add let's say 3 judge workers. Okay, let's say 3 judge workers. Okay, so let's say 3 judge workers here. Those are the judge workers. Right, makes sense. Here what will happen, those judge workers are picked up, like whatever code are pushed in the message queue like SQS, those judge workers are picked up, and then the sandbox will spin up here for each of the worker. Why we need sandbox? We already said like in the sandbox container basically user codes are there. So let's draw sandbox container. User codes are there, like we can test the case, like we can test cases, we can run environment, right? Like runtime environment, basically those are the sandbox. So we can say sandbox docker. Okay, list. Now we can test the run. Like test run will happen here. So here test run will happen. So after that, like in the similar flow in every container, code will run here with the test cases, like test case will load also. And now after this you can say the result will store in the submission DB. So after complete this, the result will store into the submission DB. Okay, so I can say result store, and it at where in the submission DB. And also we can here add the basically caching service. Like after storing the result, we can cache it. We can cache it, like store the cache also here, right? We can store the cache here. Okay, I think makes sense. So yeah, those are the basically used for, like if user submit a code, right, they can check the submissions, like how many submissions are there. So we can use Redis here for like they can show their submissions, right, their results, and also leaderboard. We can cache those things, like those data also. Okay, now going to basically detail in cache. So we can use Redis here as Redis cache with there also a database cache basically. So we can problem statements, we can cache. Okay, we can cache problem statement, and we can cache leaderboard as I say, and user statistics also. Makes sense, I think. Okay, so this way we can scale the server basically. In this way, this like multiple worker we are adding. So using this way we can scaling the systems basically. When like traffics are increased, more worker will add simultaneously, and the API servers also add here, right? We can add multiple API servers also. So yeah, and one thing, in the judge worker, just a second, I'm going to the judge worker here. So in the judge worker part, like runtime, like when you execute the code, the for the different languages, programming languages, we can add the runtime like Python runtime, Java runtime, and C++ runtime. So everything is handled by Judge0 here. So yeah, in this video like I designed a system similar to LeetCode. So thanks for watching. So yeah,